Hello, protocols, packets, and programs. As 2023 comes to a close, I often wonder if anyone knows exactly what AppSec or DevOps means or how it involves the code on our screens. We have all these tools and lists of top 10, yet find the same vulns again and again. So maybe it's time to try something new. We've got a whole show to search for a clue. Which means this week we chat with Idit Levine about service meshes, monoliths, and making software that serves people. In the news segment, Nagios phones. Hackers hack anti-fixing code to fix trains. Abusing OAuth, 5GUL, vampire code in Go, and more. Prepare for a new year and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
Hi folks, I'm Adrian Sanabria, the host of Enterprise Security Weekly. Every week, we interview the most interesting folks we can find, talking about the most pressing cybersecurity issues and challenges facing the enterprise today. Myself and my co-hosts have each been in the industry for decades, long enough to see the patterns in the industry and explore where trends are going. In addition to enterprise challenges, we also follow the vendor space, the most interesting security startups emerging, technology and product trends, all of the most interesting funding and acquisition announcements. Finally, we love to discuss the latest trends in tech and how they'll impact cybersecurity. If you're wondering how the latest in AI, quantum computing, cloud, and DevOps is going to impact security a few years down the road, you should follow the Enterprise Security Weekly podcast.
This is episode 267, recorded December 18th, 2023. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Mike, we've survived. We've made it to the end of the year.
We haven't made it to the end of the show yet, to the end of the year. So let's see if we can
Close enough.
Close enough, yeah. But for those of you who are excited about other things about the end of the year, the 2023 Cybersecurity Year in Review is here. Uncover the latest challenges and strategic responses in CRA's 2023 Cybersecurity Year in Review, sponsored by RSA Conference. From the impact of generative AI to the risks of ransomware to navigating new SEC rulings, get ahead of 2024 with a free copy at securityweekly.com/year-in-review 2023. Idit Levine is the founder and CEO of Solo.io. She has a long history in cloud, infrastructure, and open source in both startup and large enterprise companies. Prior to Solo.io, she was CTO of the EMC Cloud Management Division, a member of the Global CTO Office, and held technical leadership roles at Dynamic Ops, VMware, CloudSwitch, and Verizon. Hello, Idit. Thank you for joining us.
Hi, thank you so much for having me.
Well, we're here to talk about service meshes, but I think, honestly, what appeals to me a bit more is that it can become a team sport. So we're actually creating software in a way that is helping people. But before we talk about the people part, probably we should just set up a little bit about what do we mean about service mesh? What are we talking about today?
Yeah, so I mean, service mesh is a way to basically abstract the network from the application itself. So let me explain you what do I mean when I'm saying it. Before that, right, if someone would want to write some software, it's the responsibility of the engineer to put a lot of the operation logic inside the code. So maybe you need to import some library for security or for logging. And that was basically the engineering responsibility. The idea with service mesh is basically try to bring back the power to the SRE or the platform team, saying basically, let's not trust the engineer in a way, right? Let's verifying that instead of basically putting those hard work on the engineers, let's just let them focus on the business logic and let's us get the power back and basically writing the operation code. So the way to do this is actually kind of like inspired by the gateway way, the API gateway, which is basically by using proxy. So until now there is a change, but until now, the right approach was to basically make sure that next to every application you're putting a proxy, you drinking the IP table that way that every in and out directional will go through this proxy. And now you can have the proxy basically, you can configure the proxy to basically decide who can go, who can talk to who, collect the metrics, make sure that they will be able to connect and so on. So it's kind of like giving us like the gates, right, to our application. And now it's basically the operation team is getting back the power of decided those decision. And don't worry about the engineering putting it there. And they have to, specifically for the engineering, they, think about it. Each of them is writing in different language. So now again, you need to verify that they have all those libraries and that they including all those libraries and so on and so on. So it's trying basically to abstract, if you think, or basically seriously detach the engineering who is responsible for the business logic from the operational team who is basically responsible on the security metrics and the success of being up.
So would you, and I'm baiting with this question, but I want to dive a little deeper into that. Would you think of a service mesh as a software-defined network?
Yes, that's a very good definition of it. Definitely. It's a little bit like, software-defined network is something that we had before already. And when they were talking about it, was more just the fact that you can configure it with API. I think that this is the same idea, but I think it's taking it even to a higher level. Is right now not focused on the network, it's focusing on the application, right? So now there's an identity to those applications. And you basically, configure that the operation on the size of what the application needs versus, I need this like whatever virtual gateway, virtual bridge or something like that. You know what I mean? So it's a little bit different than the approach, but the same idea.
And part of that appeal, you mentioned too, that abstraction layer is that the platform team then can take, rather than all these microservices, I'll mention that, we'll get into that in a second, repeating a lot, the implementation, they can just go through the proxy, as you say, or the API gateway. And you mentioned identity. So this can be also mutual TLS, for example. There are already some benefits that this can introduce. So you mentioned observability. Maybe tell us a little bit of other these benefits of why it's appealing for a team just to say, you just need to do your business logic, but you're not going to lose these other capabilities that perhaps the platform team or security team are either encouraging you to implement.
Yeah, so maybe we should go back to the movement that was in the market like 10 years ago or so, which is monolithic to microservices. I think that move opened a lot of flexibility and you can go faster, you can write your code faster, you can deploy faster, but also create some challenges. And the challenges specifically, it's around the fact that if you have one big binary, right, everything is a little bit simpler in the point of the operation, in the point that you have one binary and, if there is any problem, that you can go to that binary and take the logs and kind of like make sense of it. But what we have right now is basically you took that microservice, monolithic, you cut it to a lot of small pieces, and now you need to reconnect. So when you reconnect it now, and each of those microservices potentially can scale, honestly, you don't really know even where to go to take the log if something is wrong, right? I mean, basically the request can go to and each of those instances of the services in every part of their request. So the question is if something is wrong, how do you connect where is the logs? How do you collect them? How do you make sense of them in terms of, how they align together in terms of time? And that's basically, one of the biggest things that is important here is tracing, right? Put a trace on the request and basically follow up all over the places until you're finding this thing. So it's giving us a lot of advantage in the point that it's more scalable. You can go faster. You can deploy, your application, a few times a day. But it's also basically creating a lot of suddenly complexity to how do you operate of this. And I think that a lot of the stuff that people did solve was around, how do you actually deploy those microservices? And I think that where we were weak on the beginning, at least, was how do you debug them? There was like a tweet of someone who said every time that there is, I migrate from monolithic to microservices. And every time right now that I try to basically figure out, the outrage, it's basically a murder mystery. I have no clue where to even start looking. So I think that's, as I said, every time there is a new subject, there is a lot of advantage. but also a lot of disadvantages. And I think that that's when that observability and security was one of those for sure.
A lot of that came out of the big companies like Google talking about their monolith, Google driving things like the SRE concept or that role. And so everybody suddenly, hey, it's a monolith. Let's break this into microservices because that's what the big companies are doing. So we should do that too, because that's how you be successful, is by imitating, which I don't think the logic truly holds up under scrutiny there. So, in that sense of monoliths, when does it make sense to break down a monolith, or maybe, what should you need to be aware of versus when can a monolith just stay a monolith?
Yeah, so I think the first thing that we need to understand is what the advantage of breaking it, right? When basically everybody was pushing it, why did they push it, right? Google and Microsoft and Amazon was pushing it. And I think like Amazon did it very well by defining the pizza team, the two pizza team. And the idea is basically that we wanted to make sure that, before that, when you had a monolithic and a database and so on, every time you wanted to go to production, it was a really huge dependency between the team. Right? I mean, I need to do this, but I can't change that because he didn't change that yet. And we need to go to the production. Okay, then let's do this face-to-face meeting and figure out how we kind of synchronize that everything will work. And that's a lot of people, right? It's a lot of people, interaction. And the idea was, can we actually move it to an API based, right? Can we actually give an autonomy to small team to build their use case and only their use case, what they're good at? Like, for instance, if I'm doing billing, that's all I want to know. I don't have to understand a lot about the rest of my application, but then give other team the ability to basically communicate and leverage my application. So if you think about it, the advantage with this is that now each team can go faster. They're not dependent, and there is not a lot of correlation that need to be, definitely not a face-to-face correlation, right? It's not a people correlation. It's a code correlation, which is easier, API. And the second thing is that now each of team can basically write with whatever language they want, and they can do whatever they want. It's giving them a lot of ability to go and faster and be more flexible. So that's basically the advantage of going there. So is that makes sense for a smaller company? It depends how big you are, how big is your application, what is the pieces in your application, and how many instances of the application, and how much you need to scale that application, right? In AWS and Microsoft and Google, as a big company, the correlation is becoming way harder. Maybe it's not that hard if you're the person who's doing everything in the company. And second of all, they had a big problem in scaling, and scaling, it's a big piece that is harder to do when you're talking about monolithic, because copy all that huge piece, it's just way harder than just say, I only have a problem here in that service. I only need to scale that, right? And I will scale it quick. That way better. So I think that your question is that why would someone use it? I will not use it if I have small team that can, very easily, communicate by itself. Maybe I have a one-person team that's doing everything. Definitely I don't need, to split their responsibility per se. And the second one is that maybe scale is not a thing, right? Maybe I have an application that it's very simple. I need one instance, probably will never need to scale because I don't have a lot of. So that's another one. And again, it depends on volume, basically, how many applications you have, how complex it is running it. If you have one application and you need to put security there, you can go to the engineer and say, make sure you included that. When you have a team of, hundreds of engineers everywhere and you need to make sure they're always doing it, rather, take it out of their hand and make sure that you're doing it. So again, this is, I think, where, kind of the balance. What we personally see in the market is that mainly, the organization, the enterprise organization are the one that basically will be interesting in a service mesh. And a lot of the other will mainly use, just, interaction between people, I guess.
Sure. And I think it implied to the answer, too, is that the company is big enough to have a team that can actually own that platform, own the service mesh, rather than have that diffusion of responsibility where each individual microservice owner says, well, I'll take care of this part. Maybe I'll take care of this part. And suddenly something goes wrong and nobody knows what to fix.
Exactly.
Speaking of fixing, the observability, you were very focused on the debugging, the tracing. Here's a request that came in. How do I know which microservices it pinballed around and hit? Tell us a little bit about that, including the security dimension, because, fingers crossed, at least we're not losing visibility from a security perspective, but hopefully we're also gaining something as well.
Yeah, so I mean, think about it. Before, a lot of the work of the security team was related to IPs, right? I mean, basically firewalls. Um, it worked very well for us until today. It's still working well, but I think that in an environment like microservices, that could be a little bit more challenging. If you're looking at something like Kubernetes, potentially the IP can change, right? Which is definitely a security problem, right? So can you actually change the policy as quick as the IP change in the pods and so on? So I think that in the Kubernetes world, we're talking about identity and not IP. We basically, right, we're using identity. So that's number one, that is extremely important. So now the question is, how do you protect? Like, what are you doing there? So I think you mentioned MTLS, which is a very, very important piece of it. We basically have identity to each. Sorry. We have identity to each of the service and the client. So if you are familiar probably with TLS, right, which is basically the certificate to the server. So now in Kubernetes world, we're basically also talking about MTLS, which is mean that also the client is basically getting the certificate, and we know that who is ever talking to us supposed to. So that's number one. So everything that related to policies, and again, the best way, and this is where service mesh is different than maybe CNI, is the fact that you rather put those policy on the level of the identity versus the IP, who could potentially change, and you will have some vulnerability that could happen because of it. It's very not likely, but could happen. So that's kind of like in terms of the MTLS. In the terms of the team, I think you talk about we're talking about tracing, which is debuggability, but we need to talk also about metrics, which is very, very important. And when we're talking about metrics, the SRE team care about the application being up and running, and right. So you need to take care about the metrics. Like the golden metrics is probably what they care about. But when you're looking at the CISO of the world, the security team, I think that they are more interesting of trying to figure out problem, like for instance, DDoS attack. Right? So if you're looking and you see that there is a lot of problem with red limiting, and we're red limiting a lot, but potentially can be a DDoS reason, right? If you're looking at, for instance, you're getting a lot of 401 or policy violation, like there is a lot of requests and the policy basically need to deny, again, could be dangerous, right? Could be some potential problem there. So I think that what they're looking more is the stuff that related to security in that part of those metrics, versus I think that the SRE team or they more care about, the application is up and running. That's the thing that mainly they care about. So I think it's just different metrics that they care about in a way, or maybe they're looking at that metrics.
Yes, and especially the SREs love their availability. We just want it to be running, and they're looking, as you said, they're looking at some of that activity that might be bot activity, just people scraping, people doing credential stuffing attacks, things like that. I'm curious too how you've seen that security aspect come in, because a lot of it at that point is a platform team looking at platform layer types of vulnerabilities, which makes sense. It's in the names. That's their responsibility. But that business logic is actually still in each of the microservices. So I'm curious, how have you seen this with bug bounties, people that are looking, finding those cross-site scripting, finding those business logic types of attacks that are playing around with implementation flaws in a workflow or in a logic of a application, and how is that either making sure it's still just as debuggable for that type of engineer looking at their own microservice, or even security team trying to understand just what's going on in general?
Yeah. So do you mind to repeat the question? I'm sorry, my dog is he's shouting.
No problem.
Get into the room, so it's taking like I don't know. Maybe
we love all the pets here, so my cats will show up in a bit too. But to try, it's always a good challenge for me to try repeat a question concisely. So let me say, no, I know, I'm talking to myself. Trust me.
Don't repeat. Just giving the eye level of it. And
there is the aspect of the business logic. So we have, as you were describing, the platform layer types of attacks, visibility that the platform team is interested in. There's also the business layer, cross-site scripting, kind of a simple example, or maybe they're just, repeatedly applying a coupon code during a checkout process, or things that type of business logic that is actually more specific to the microservice itself. How have you seen either the logging have to make sure it still accommodates that microservice owner, or do they things that tend to be forgotten because this doesn't just microservice is what I'm getting at. Doesn't mean suddenly security is just the platform team's responsibility. I'm curious, have you seen that?
So the engineer themselves care about one thing, which is writing the code, make sure that it works. If there is any problem, that we want to see debug it, ability to debug it and understand what's going on and why it's wrong. In terms of any problem in the application, the SRE team less care about the business logic, more as you said about, is it up, is the policy in force, does he, the golden metrics is something that they will care about the most. So they just seriously care about a different thing. I think that the SRE team does not will care enough about the business logic. They more care about making sure that the application is up and running. I don't know. I don't know if this is the direction that you wanted to go with.
Yeah, I don't know. And maybe not.
Yeah.
It's definitely an open-ended question. Maybe asking a slightly different way is, what is we haven't talked necessarily even about where an AppSec team comes into here, or in the aspect of when you've talked to customers or you've seen this, do you see that AppSec role tend to be the engineering role, meaning they are working with the platform team to build guardrails in the Netflixy style paved roads type of way? Or do you see the AppSec team as more of that? Have they acted more as a governance role, just saying, here are requirements,
Yes.
and they hand them off and say, please implement. I'm curious if tell us a little bit how you've seen that work and how you've seen it be successful.
Yeah, no, so definitely. So what we saw from our customers is, that the SRE team or the application team or the platform team, is the one that actually interesting in the service mesh because it will help them operate and so on. And then they need to pass security though, like the guys, the team of the security need to sign in. They usually have their own thing that they wanted to look at. I don't know, like maybe it's FIPS compliance that they're interesting. Maybe they're looking at IPsec. They're looking to see what is the thing that they are interested in and making sure that is important to them to sign in. That's what we saw most of the time. So they're signing in. Once they're signing in, honestly, I'm not 100% sure, as I'm not the one who's actually deployed that on live. But what I know is from the size of the when we are selling it, when we are partnering in live, I'm assuming that there is an interaction between those teams. But I think that the majority of the policies enforcement is run actually by the SRE team. And I think
so. And when we do this, I'm curious then, where have you seen successful abstraction? So we talked about this is an abstraction layer for logging, yes, for identity, that mutual TLS. So we don't have to. We don't have to re-implement. We just have to make sure we have language support for a particular library. Are there certain libraries, open source tools, or techniques that you've seen teams adopt that be more or less successful in this area?
No, so I mean, one of the things that is very important if we're talking about observability, for instance, and open tracing. So there is, still a library that you need to actually include it and propagate it. The basically propagate the packages called the bags. So that's libraries that people using it. The idea is again is like that you don't need to, like, we don't want the engineer to need to deal with this. So the idea is that all the connectivity on the stuff is not a tooling that the engineer need to even know about it, right? They just need to do basically focus on the business. If they want the debugging, they do need to include the open telemetry libraries. But in the nutshells, again, the idea is to take this responsibility for them. And also, again, we don't want to create right now libraries in different language. So, we'll create the one we have to, but in the nutshells, everything that we can basically, delegate to the proxy will be better, right? And then everything is YAML. Think about also the other thing, like, let's assume just back of it that right now there is any, CVE in the proxy, which could be happening sometime, not often, but it do. Right now, for instance, the way it's working, every time that there is a CVE, we need to communicate. Or in general, every time that there is operation code, let's say that I wanted to upgrade the library of the operation code that I'm using. I need to go to the application team and tell them, hey guys, we need to redeploy the application again. I need you to, go with another library and then basically deploy. Honestly, the business logic didn't change at all, right? I mean, it's the same business logic. There's no reason to create a new version of the application per se. So by actually abstracting that, you're getting to a very nice way of less dependency between the business and the operation. And in service mesh, we're actually taking it one step ahead. So we talked about open source as a proxy, working with proxy. So we're calling it sidecar, each of application as a sidecar. So we kind of like abstracting in that way. If you think about the application, like we kind of like trying to detach the business logic from the application use case. But as I said to you, if for instance there is a CVE in the proxy, you still need to go to the application and tell them, hey, we need to redeploy it. So again, a connection between people. What we're doing right now, and we basically announced a year ago with Google, is basically, and we donated to the open source STO community, is basically what's called ambient. And ambient is a mode of STO that the purpose is exactly that it will be ambient, that it's not going to be, that it shouldn't be as connected. And the idea is this: instead of putting a sidecar proxy next to each application, in the world of if you're looking at Kubernetes, what we're calling a sidecar, there is some issues with this, right? You can, for instance, if the application is up and the proxy is not up yet, it's not going to get there. There is a lot of kind of like challenges if you wanted to, as I said, upgrade, the proxy, you need to upgrade the application. There's a lot of connectivity, so we kind of like try to abstract it and basically detach it, the business logic from the operation logic, but honestly, in a way, we kind of like they still need to communicate. So what Ambient is supposed to do is basically we're using right now one proxy, and we're using IP table or if we need eBPF to basically redirect all the traffics to that proxy. And basically in that point, there is a daemon set of your node. So, it's not hard to install it, and you don't need to, it's not a package together in a pod with the application itself. And in that point, what you can actually create, you can get to a point that it's really abstract. And the reason is because now the business logic for real, does not attach to the proxy. So if there is any problem with the proxy, I can replace the proxy, upgrade and do everything. The application will not even know. The application can run, right? In the sidecar today, we have to redeploy the application when we want to implement a mesh, because it have to be as part of that deployment. But in Ambient, there's no problem. I can have an application that's running for years on Kubernetes. I can just apply a mesh. Then I can say, policy, like, I don't want this one to talk to this one or whatever. And it's just going to work. So it's basically forcing the MTLS and all the policies without really be very attached to the application. So now all the stuff that I was talking before about the abstraction, it's a real abstraction, really, really real abstraction.
Yeah, I like that. I was going to say, I like that decoupling of we have to coordinate our releases, or we have to coordinate here's the update versus here's the redeploy, because that, again, that brings the stickiness where teams actually have to do things together. But I still see, in the days that I see, teams are always having to redeploy anyway, because there's their own application layer dependencies, their packages, as well as it seems nice that just redeploying early and often is a good dynamic to have. You're getting your base images updated and so on. But that coordination is having that be more loosely coupled sounds appealing. I'm curious then how trying to think of how to phrase this easily is that talking about like the proxies, how it's the business logic is kind of agnostic of what's going on at the network level. It doesn't have to deal with those network decisions. What does that mean for then the compromise situation, or how you've seen, like you mentioned, like there may be a CVE, there could be the pivoting through microservice to microservice. How does this help, this visibility, observability, help your incident response team or your detection and response team, however it may be named within an organization, who's potentially worried about attackers walking from service to service with an impersonated identity?
Yeah, so I think that in that case, this is where MTLS and the zero trust is basically coming into place. That's basically what Mesh is trying to do, right? It's assuming zero trust, And therefore creating a relationship between those microservices in an MTLS style, which means that we knows that, so that's number one, right? First, let's make sure that all of them is MTLS. And that way we know that whoever is supposed to talk to whoever, is the real people, right? The identity is not the people, it's the real services, right? The second thing that we need to work then is policies, right? Who is allowed to and what are they allowed to do? And that's basically where, the policies are coming into place to say even allowed to do. I mean, the way I'm looking at the service mesh, think about like you have two doors or two houses, right? And you want basically to create the road, between them, right? That's basically what the networking is doing, right? They're making sure that everything is accessible to everything. I think what Service Mesh is doing really, really well is putting basically a guard in each of those places, right? And he basically said, yes, we make everything, reachable for everything right now, but the guard is basically going to make sure that, it's allowed, right? In a way, it's the best way to describe it. I personally think that the best way to do it is do what's called defense in depth, which is basically, do we even have to create the road, right? And that's where I think that more interesting thing is we can do with, for instance, something like CNI and eBPF like Cilium, right? Can we actually get to a point that we're saying, listen, this thing not supposed to talk to this thing, so yes, we will force it by the guard, but we're also not going to create the connection between them on the lower level. Does that make sense?
It makes sense. And I love the direction of that. It always seems in practice potentially harder. eBPF, just notoriously, it can be persnickety, to use one judgmental word, about getting it configured correctly, or having it not block legitimate or desired traffic. So I'm curious how you've seen that in the sense of, a policy as code approach, or ways of just having something as code, service mesh as code, which I just make up right now, in the sense of enforcing these types of access controls so that they can be reviewed, audited, reasoned with in a level that humans, like YAML files, that you and I could understand, rather than a low-level eBPF, perhaps.
So exactly, right? I mean, if you think about, let's say that you have today a Kubernetes cluster. The first thing that you need to make sure is that you will have what's called a CNI installed. And a CNI responsibility is just to make sure it's an overlay network. You just need to make sure that you can access the pod as basically a way to access each other, right? This is kind of like the first level. What Service Mesh is coming and basically putting more, basically in a way above it, policies, MTLS, and so on. So when you asking about how can we make sure that it's forced, to me, when someone telling me that this container cannot talk to that container, as I said, I can translate it in a YAML, right? And this is what basically Service Mesh made, to a very easy kind of like, a policy in STO, for instance, right? But it would be very interesting if the same YAML will also go to the network policy, a Kubernetes network policy, and basically enforce it there as well. Now, as you said, eBPF is a very low level. No one expecting you to do that. There is CNI like Cilium that we are working a lot with, that's basically giving you this more like, nice level, API. I don't know if you're aware of Kubernetes network policy, and there is right now the V2 that's coming up that is very exciting. And Cilium has their own kind of like version. But in the nutshell, that's everything that's related to a Kubernetes network, but it's on the IP level. And that's very, very important. All those policies forced by the IP level. I think what Service Mesh is bringing on top of it is basically the identity level policy, which I think it's very important, definitely in an environment that potentially the IP could change, very, very rapidly. So again, that's basically where I think that it's coming. But both of those projects that I'm, either Cilium or STO, both is all YAML oriented, talking about the policy and what the policy that you want to force, and going and implementing it either in the proxy or in eBPF, right? That's the data blend that's basically forcing it. Yeah.
No, and this whole time I'm trying to think of a good metaphor as you're describing, the guard at the door, something about the dog who wanted to come in, because we've got an identity here. So I do have to ask, what's the name of the dog, because we heard him in the background. So
yeah, his name is Apollo.
Apollo, wonderful.
Yeah.
As we do start to give Apollo back some time, what's a good call to action? Where can people find out more about what you're working on or what you're doing?
Yeah, so I think that, we are very, very passionate about security, observability, and networking. Always when you're talking about networking, you're talking about connectivity, observability, and security. This is what we're doing. This is what we know very, very well. We're doing it on the level of on the gateway. So we have a gateway that we are focusing there really quickly. And then one of the best, and we also implemented there WAF and a lot of other security. We have a very, very big, with OPA and JOT and, a lot of kind of security on the gateway. Then there is the service mesh. That we are very, very passionate about that's giving you those stuff as well, observability and security, including connectivity. And we're going all the way to the next layer, which is basically the CNI, the container network interface, and Kubernetes network policy. Again, all of this is bringing you more observability, just in different layers, right? I mean, so that would be very interesting to take all that data and basically force it. This is what Solo doing. This is what we are doing really, really well. And where you can find us, our website is a good start. But we also have a big open source community in Slack that I will really recommend you to join. There is a lot of very, very smart people that can answer a lot of good answers.
That's awesome. And we'll make sure to include those links to that in our show notes. Now, in 2023, we've asked for 3 words to describe AppSec of all of our guests. So you mentioned while you were telling, all that data sounds like almost a good start. But I'm curious what your response to this would be as we close out the year with all of our guests.
Yeah, no, I was thinking about it a lot. And one of the things that I came with, I don't know if it's great, but I think it's good enough. It's protecting software integrity. I think that's what it's trying to do.
I love it. Yeah, no, we've had wonderful, very varied responses from everyone throughout the year. So it seems like there's a lot of work that AppSec needs to do, whether it's at the service mesh and identity and observability, or at the business logic or different layers. But in any case, Idit, I want to say thank you so much for joining us, as well as hello to Apollo. Thanks for joining us as well, and helping us to close out the year of the show for us in 2023.
Thank you so much, guys. I really appreciate it.
Thank you again. Thank you to John. We're going to take a quick break now and then return with news of the week.